The number of kilograms of water in a human body varies directly as the total weight. A person weighing 63 kilograms contains 42 kilograms of water. How many kilograms of water are in a 90 kilogram person? This is an example of a direct variation given by the statement varies directly. In order for us to solve for this, we need to really identify what is the correct independent and dependent variable. In the statement, the number of kilograms of water in a human body varies directly as a total weight, we know that the number of kilograms of water is your dependent variable. And we can assume that this is represented by a variable y. This also means that the total weight of a person is now your independent variable represented by the variable x. We will be using these representations in solving later because the correct mathematical equation that corresponds to any direct variation statement is given as y is equal to kx, where k is known as the constant of variation or constant of proportionality. We will then plug in the values here later in order for us to solve the unknown, how many kilograms of water are in a 90 kilogram person. But first we need to identify what are the values of x and y that will be placed in this given situation. X, as mentioned, is the weight of a person. So for the statement, a person weighing 63 kilograms, that's your x, contains 42 kilograms of water. That's your y. We'll be using that to solve for the value of k and then be applying that value of k to solve for the unknown. So first, we know that the first pair of values, that for x, for weight of a person, if a person weighs 63 kilograms, y, or the number of kilograms of water for that specific person, is 42 kilograms. This is the first pair of values given. And then we'll be using, again, this to solve for k to get the unknown. But first, 90 kilogram person, that's your second independent variable. And you're looking for the value or the number of kilograms of water for a 90 kilogram person. That's your y. So this is now the situation, and we'll be using this here. So we will solve for k first by plugging in the first set of values. So y, that's 42. We are dropping first the units because we are just going to compute it mathematically later, algebraically, is equal to k times 63 kilograms. We will use all the possible fundamental operations, including the properties of equality, in solving for k. So here, we'll be dividing both sides by 63 to cancel this out. You'll also be doing that here. So applying the symmetric property, k is equal to 42 over 63. Now this might be too large for some, so we need to simplify it. So we could just use k in simplest form, 2/3. This is known as the constant of variation or the constant of proportionality. This is the same value of k for the same equation in finding the next unknown value. So we will be using that here. Y is equal to k and x. We now know that the y is what we are looking for, so it stays as y. K is already solved as 2/3. The value of k will not be changing on the same situation, so we'll be using the same value. Times the given kilogram, or weight of a person is 90. So whatever will be the result for this is the answer to the number of kilograms of water in a 90 kilogram person. So we can divide it like this. 90 divided by 3 is 30. So we can say that y is just simply equal to 60. To close this process, we can declare here that there is 60 kilograms of water in a 90 kilogram person. This is how we solve this problem. The more you practice, the better the chance to understand math. This is a direct variation statement for math success. Let this K, the constant of variation, be this channel. In other words, the more you practice with your subscription, the better the chance to understand math. Subscribe now.